In a previous session, we talked a lot about security and a lot of those funny acronyms that go around the technology that's used for it. Things like secure access, service edge, SASE, and all the stack of things like DLP, CASB, SWG that are used to protect those users when they're accessing SaaS apps and web apps on the internet. And so, now we're going to dig in a bit more about on the back end. We talked a bit about it, Web Application Firewall, but today we're going to dig into a bit more about what that can do to protect, web apps either, in the cloud or on premises.
I'm actually impressed that you remembered what SASE stood for, because that's the one acronym I just can't remember what all those letters mean.
I had to look it up a few times beforehand.
So, when we think about SASE, like as Matt was saying, like web apps and from a Citrix virtual app and desktop admin or architect perspective, it's like, oh, this doesn't concern me. But if you're using an on-prem gateway, it actually does, because your initial authentication of using gateway to authenticate the users, that's a web application. And that's kind of an important web application, because that's what your users are using to log into the environment. So it's kind of important that we need to be looking at how do we protect that even more.
Yeah, it is definitely a web app, and I've gotten that question a lot. Right? It's gateway, on-prem gateway has always run on an ADC, and so ADC has all these great capabilities, and I've always gotten the question of like, well, hey, I've got this security capability of this on this ADC. Like I've got Web App Firewall, and in the more recent builds, I've got bot security. Why can't I just use that for gateway? So yes, it is a web app. It has a web front end. It does some authentication stuff, but in the way that the traffic is processed on the ADC, it's a little bit unique. So we do have to take some things into consideration, but to your point, right? It is just a web application, so there's a whole host of things that we can apply to your gateway installations to have some of the same protections that we've been used to when you're just talking about traditional, IIS or Apache web services. So we're going to talk a little bit about Web App Firewall. And what we're actually going to do is we're going to use WAF, Web App Firewall, to protect the form submission, such that it's a form, right? So you've got username and password fields. Well, that can be potentially used to do some malicious bad things. We're going to talk about bot mitigation and bot security, right? So gateways are they're a little unique. Normally for like e-commerce sites, you want to let the good bots in so that they can see what your site is and do some basic analysis. But for gateways, we probably don't want any bots, good or bad. Then advanced authentication. This one goes back to the N factor, or as I like to call it, any factor. You can build out basically a business use case around authentication. And then this is an ADC, right? So we do want to have some DDoS protection as well, between rate limiting, IP reputation, GeoIP, among others, to protect the gateway. So I'm going to hop over.
What is? Hang on, I'm curious. Do you know, like, what is a good bot?
Yeah, so a good bot is a bot that's run by it doesn't have a nefarious purpose. So for example, Google search bot is going to look at your site. It's going to scrape a basic, grab some basic heuristics. It's going to pull down the site, and it's just using it for basically cataloging and web searching. So that's a good bot. It's not a human being. It's just a service that's running from Google. So that would be a good bot. A bad bot is something that's trying to go out to an e-commerce site or like an eBay or Walmart or whatever, that is grabbing and buying things and then reselling them at a higher price, right? So that would be like stock manipulation. So that's a bad bot.
And the Borg and Cylons would be bad bots too.
Exactly. Those would be bad. So what I'm going to do here is this is just a gateway virtual server, right? It's got a username and a password. So this one is specific to App Firewall. So what we're doing is we are protecting the form submission. So I'm going to type in my username here, which is of course Rutski, but then I'm going to put in some SQL, right? I'm going to use try to do some SQL injection. So I'm saying Rutski or 1 equals 1. There's a few, single ticks in there because that's SQL. But what's happening is it's saying, okay, no active policy. And what we're doing is if we go into the log, you can see that the SQL keyword failed for the field login of OR, and then you've got that single tick there. And you can see that it's the WAF profile was the one that was hit. Now, if we go back and let's talk a little bit more about App Firewall. Due to the way that the packets are processed by the packet engine, you can't just apply the application firewall policy to the gateway virtual server itself. Just in the way that the page is rendered and the order of operations within ADC. So you have to do a little bit of a non-standard configuration. You still do create your WAF policy and you create your signatures and those sort of things, but it's a little bit more out of the way or non-standard, like I said, using an HTTP call out. So there is a TechZone article out there that was written recently that goes through the whole configuration for most of these. So that's Web App Firewall. Advanced authentication. Let's talk on that for a little bit. So when we think about advanced authentication, usually we're talking about N-factor. And what N-factor allows you to do is to take a business use case, whether it's mergers and acquisitions or whether it's building context around different users, where the users are coming from, if they're in a different state than their home office, maybe they're on vacation, that sort of thing. We can use N-factor to, for example, look up their Active Directory user object, and if they have populated a state where their home office is, let's say it's Florida, and they're coming from somewhere else, like let's say Minnesota, then using N-factor, we can say, okay, hey, wait, you're coming from somewhere else using our GeoIP database. You're coming from somewhere else than you normally are. That's outside of your home state. So I'm going to make sure to prompt you for an additional factor. Maybe that's a verification, an SMS, or a phone call, or another a third-party integration with a TOTP. So that's that building context around the user and understanding who they are and proving who they are.
Jacob, yesterday the last session we talked about zero trust, and this is kind of a bit about taking away some of that trust. It sounds like.
Right. So if we just say username and password and you're good, right? That doesn't really do any good, and that doesn't apply to zero trust. So what we're doing, right, is we're saying, okay, we don't trust you. So you really do need to prove you are who you say you are. And so obviously there's a very fine line in zero trust where we know that it's the user and we don't want to get in their way, but at the same time we don't trust them, right? And so we need to make sure that they are absolutely who they say that they are. So let me hop over into the next demo here. And what we're going to do here is we're going to go through some, we're going to look at bot mitigation, bot security, and leveraging the IP reputation. So what IP reputation does is it's managed by a third party, and it just constantly updates every 5 minutes, gathering lists of known malicious IP addresses. And so when you build that into the configuration, what we're going to do is we're going to take this a step beforehand, where we're not even going to render the gateway login page, and we're just going to block it altogether. So what we'll do here is I'm going to log in with a Tor browser, and I'm going to log in and launch my public-facing site. And you can see here it's just going to sit and spin for a minute. I've actually sped it up, but it's not going anywhere, right? And if we look at our Tor connection chain, you can see that I think we're coming in from the Netherlands, but the last node is the Tor exit node. And so if we again look at the logs here, we can see that my connection was dropped, right, because the bot profile disallowed the malicious IP. So even though this is a bot profile, right, it still applies to that front end security where I am not going to let you in. I'm not even going to render the page, let alone, try to give you oh, hey, this is a gateway username and password. You're not even going to know that anything is here, right? So this kind of blurs the line a little bit between bot security and some of the other DDoS protections. They certainly apply in both cases, but there's a little bit of overlap with IP reputation. We're applying it both on the bot security as well as on the DDoS policy as well.
Makes sense. So it's just
there's a number of
it's eliminating at the network layer a lot of bad known actors by just looking for those IP addresses. Yeah.
Yeah, and so it's a little bit of a kind of a brute force hammer. The more that you can apply, the better. So if you take the whole list of IP4 IP addresses, you can kind of chunk down who's allowed. So you can say, okay, if you're a known malicious IP, you're out. If you are in certain countries that that should not be accessing, you're out. If you are only in a single country, you can really limit that list down. Obviously, if you're a global organization, then that number is slightly lower. But then, of course, you apply the traditional DDoS of rate limiting, SIM cookies, and that sort of thing to also chunk down just at the network layer, who is allowed to access, and we can kind of tell that they're not supposed to be accessing based on the rate or based on where they're coming from. We're gonna say no.
Makes sense.
Yep.
Digging in a bit more in the Web Application Firewall, I mean, sounds really important, man. They say most attacks happen over a few ports, particularly like 443, right? So we know there's a lot of traffic that's going to be hitting that gateway and other things beyond the ADC that shouldn't be. So maybe you can tell us a bit more about how does WAF actually work? How does it decipher what's good traffic and bad traffic, and kind of without interfering with the performance and and letting those good sessions get set up?
Yeah. So yeah, you're absolutely right. I mean, most traffic comes over 443 anyway. Everything is encrypted at this point. Fortunately, we know that the gateway, it is unique. It is a unique website, web service. So we do have a good idea of what server technology it's running on, what signatures we should be applying. And so that's kind of that negative model of, hey, look, we know that there are known attacks. So perfect example is the Exchange vulnerability that came out recently. We know that that's obviously being exploited, in the live. And if you happen to have an Exchange server that's front-ended by an ADC that has the WAF policies turned on, once that attack was known, we released signatures that would have auto-updated and been pushed down to all the ADCs. So at that point, that signature has been applied, and we know exactly what to look for when we're blocking. So that's the negative model. But we also support a positive model, which is, we know what the normal traffic looks like. We know what the form fields look like. We know what the cookies look like. We have a map of, kind of like a URL path, like breadcrumbs of where the user is going from page to page to page and how they can get to certain pages. So if they all of a sudden jump to, let's say page 7 in the chain, and they didn't, first hit 1, 2, 3, 4, 5, and 6, we know that shouldn't be allowed. So those sort of things we can block for and we can prevent from happening because they didn't follow that that known good path of, hey, this is how this application works. These are how you get from page to page to page. This is what cookie we expect to see. This is the form field that we expect to see. So if you start going out of order, or if you start tampering with some of those objects, some of those cookies or some of the form fields, then we're gonna block that connection altogether, right? So even if we don't have a certain a signature for a certain attack, the positive security model really helps you to block and prevent attacks that are not known yet, right? So it's the 0-day attacks where there's that time between when an attack is seen out in the wild and when we get a signature applied for it. So there's a little bit of space between when you'll have a signature. So with a positive security model, you have that protection even if you don't have a signature. So we support both on the app firewall.
One of the things you're talking about when you're trying to integrate Web App Firewall with the Gateway virtual server, it's kind of a roundabout way you have to do it. So, I mean, typically when a user would hit or try to get to a gateway virtual server, they would hit an authentication virtual server first, which then sends them to the gateway. Is that right? No, it's the gateway virtual server, which utilizes an authentication virtual server. How does the web app firewall tie into that whole communication flow?
So it's a little bit wonky, right? Because gateway and authentication virtual servers are kind of the unique ones. So that it can be either or, right? A gateway virtual server can do authentication, or you can kind of redirect on the background. So what we're doing is we're protecting the form submission, and so prior to submitting the form to the authentication engine, what we're doing is we're taking the entire page and we're sending it out via what's called an HTTP callout, and we're sending it out to a basically a dummy virtual server that's just listening, that has the WAF policy bound to it. So we're taking that form submission and we're looking out for SQL injection, cross-site scripting, running it against signatures to make sure that all those things that we want to protect against are not being submitted back. Obviously there's not a SQL injection, there's not a SQL server behind authentication, but those are some of the protections that we expect to see, and some of the things that we expect. So what we're doing is, we're grabbing it via the HTTP callout and checking for those protections, and then sending it back to the authentication engine. And if there was a block from the app firewall engine, then it's going to basically go nowhere. So it's going to render that page that says, "Hey, there's no active authentication policy. Sorry, you go nowhere." Otherwise, if it comes back clean from the app firewall engine, then it will just step through the remainder of the authentication engine.
So in a sense, we're protecting the ADC itself in some regards.
Yeah, I mean you're protecting both from the rendering of the gateway page via the bot security, and all the the IP reputation that's tied in front of it, and then you're also protecting, once it's rendered, from the submission of the form. So you're protecting the whole chain there.
Yeah, I think it's important, especially considering everything that's happened. Users are no longer in a secure environment anymore. A lot of people are still working at home. A lot of people are on untrusted endpoints, so you don't know if those endpoints have been compromised. So, the user, you might not have a risk with the user themselves, but you might have a risk with a compromised endpoint, since these are all untrusted now. And so, we're only talking about we're only talking right now about protecting gateway on-prem, but if you were utilizing like secure workspace access that we talked about previously for the whole ZTNA, you could leverage this functionality around those internal web applications that a user's trying to access through a ZTNA framework as well.
Right. Yep. I mean that's what Web App Firewall is built for, is web apps and web services, to protect from the outside world, the big bad internet. And if users need to access them, we need to make sure that they are protected, even if we might trust them a little bit, but again, with zero trust, that's saying we don't trust them at all. So we need to make sure that they really prove who they say they are, and that they only get access to the things that they absolutely need, and not everything else.
Cool. I think I now have a pretty good understanding of Web App Firewall and bot protection. Thanks a lot.
Sure thing.
Thanks, Jacob.
You bet.